Welcome to Study Loop.
This is the answer to Chapter 21, problem number 79 from the Smith Organic Chemistry textbook. This problem says reaction of 5,5-dimethoxy-2-pentanone with methylmagnesium iodide followed by treatment with aqueous acid forms cyclic hemiacetal Y, and we're asked to draw a stepwise mechanism that illustrates how Y is formed. So this is basically just a Grignard followed by an acetal hydrolysis. And then the alcohol that we make in the Grignard is going to attack a carbocation that we form during the acetal hydrolysis. So let's go ahead and get started. So the first thing that's going to happen is going to be our Grignard. And so that is going to look like this. So typical Grignard mechanism here. And the result is going to be the alkoxide that we expect from this Grignard. So we've added a methyl group here. We have the alkoxide here, 3 lone pairs and a negative charge. And so the aqueous acid that we're using as the workup here is going to protonate that alkoxide. Then actually, I'm going to draw a protonation of one of these other oxygens at the same time. Try to save a little time here. Okay, so this oxygen now has 1 lone pair and it has a positive charge. And so, of course, the next thing that's going to happen is going to be that this leaves as methanol. And so now we have a carbocation here. And that is going to be attacked by water. It's always good practice to put all your lone pairs in on heteroatoms. So there we go. So water is going to attack that carbocation and add. Okay, and so now we have a positive charge and 1 lone pair on this oxygen. And as you might expect, the next thing that's going to happen is deprotonation of that oxygen. By another molecule of water. Okay, put my lone pairs in. And so from here, the remaining methoxy group is going to be protonated. So we'll use another molecule of H3O plus. So that protonation will occur like that. And so now there's only one lone pair and a positive charge on this oxygen. And so now this can leave as methanol, just like the first one did. And so again, just like above, this will leave us with a carbocation. So we have a carbocation here. And now what's going to happen is attack from the alcohol at the other side of the molecule. So attack like that from one of these lone pairs. And so that makes our ring. And our ring is going to look like this. Looks pretty ugly. Try that one more time. Our ring is going to look like this. It's better. So we'll have an alcohol here, two methyl groups here, and this oxygen still has its hydrogen. So there's only one lone pair, and there's a positive charge. And so the last thing that needs to happen to get to our final product is going to be deprotonation of that oxygen. And that is going to be accomplished by a molecule of water. And that is going to yield our final product. Okay, and so this is molecule Y, as the problem calls it. And this is the stepwise mechanism. So again, it's a Grignard reaction followed by hydrolysis of an acetal. And then at the end of that acetal hydrolysis, the carbocation that is formed is just attacked by the alcohol that we formed in the Grignard step. And then that resulting tetrahydrofuran is deprotonated. And so we get the cyclic hemiacetal product Y. And that's the answer to chapter 21, problem number 79.